Hey math kids, today we're just going to review some ways to solve for x when we have quadratics. And so if we start with something that looks like this, I'm going to show you how to use box method to solve. So we've used box method to factor, but we didn't quite take it to the point where we solved. So if box method is confusing to you, make sure you watch the video that's dedicated just to that one method before starting this one. We're going to go over a few other methods as well. So first we're going to do box method. So we're going to say 8 times 15. So we pull out our calculator. 8 times 15. And we get 120. So once again, you just multiply this by this, see what you get, and then break it down. And we're trying to find factors that add up to the middle term, which is negative 22. So we have 1 times 120. 2 times 60, 3 times 40, 4 times 30. We're not there yet. 5 times, 5 times 24. That's not it yet. 6 times 20. That's not there yet. 7 I don't think will work. 8 times 15 works though. And that doesn't quite add up to what we want. 9 I don't think is going to work. 10 and 12. And 10 and 12, if we make them both negative, will add up to 22. And also if we multiply them, it's positive 120. So that's definitely what we want. Now remember, the goal with box method is we're actually splitting this term. So it's going to be like negative 10x, negative 12x. So we draw our box. And we write the first term right here, 15x squared. Write the last term here, 8. And then the other two that I wrote in red, we put there. Now we want to factor out what we can. These have 3x in common. These have 2 in common. These have 5x in common. And then these have 4 in common. Now since we have a diagonal of negatives, we're actually going to tack negatives on there, but then just as a safeguard, we're going to multiply and see if we get the same sign. So 3x, 5x, 15x squared, 3x, negative 4 works there. Negative 2 in this makes that. Negative 2 and negative 4 makes positive 8. So we have 3x minus 2, 5x minus 4. Now remember, this thing in purple is equivalent to this thing in white, so this actually equals 0 as well. And what we're going to do is we're actually going to break this up and solve each of those individually for x. So we're going to say 3x minus 2 equals 0. And then we're going to say 5x minus 4 equals 0 as well. Okay, we add 2 to both sides. 3x equals 2. Divide by 3, divide by 3. X equals 2/3. Over here, we're going to add 4. Add 4. 5x equals 4. Divide by 5, divide by 5. So x equals 4/5. And those are the two answers to that. Okay, now I'm going to show you a similar method, but we get x squared plus x minus 20. Okay, so that doesn't matter. So 20, this is equal to 0. So this is one that we can use regular t factoring. So we're going to do a t right here, 2 and 10, 4 and 5. If we do the 4 and the 5, but we do a negative 4, those would add up to the 1 that's right here. If we multiply them, they make a negative 20, so those are the right ones. So x minus 4, x plus 5 equals 0, because the thing in blue is equal to this. And once again, like on the previous problem, we just break it up into 2. So we say x minus 4 equals 0, x plus 5 equals 0. We add 4, x equals 4. We we subtract 5, so x equals negative 5. And those would be the two answers using t factoring. Now, if we have something that looks like this, we can also use completing the square. So I'm going to add 4 to both sides. Then I'm going to divide everything by 15. So that leaves x squared plus 4/15 x equals 4/15. Then we do the L step. So that would be 2/15 and then 4/2/25 because we divide by 2, which I just divided the top by 2, and then I squared the top, squared the bottom. Now I'm going to add that to both sides. So now I get x squared plus 4/15 x plus 4/2/25 equals, I'm going to move this over here, 4/15 plus 4/2/25. Okay. Now simultaneously we'll do both sides. So I get x, and then I do the elbow, which is a positive 2/15. And then over here, I need to multiply this by 15/15. And so that is 60 plus 4, so 64/2/25. Then I square root both sides. X plus 2/15 equals plus or minus 8/15, because square root of 64 is 8 and square root of 225 is 15. Now I subtract 2/15 from both sides, and I get x is equal to negative 2/15 plus or minus 8/15. And so we would have negative 2 plus 8, so that would be 6/15. And then we'd have negative 2 minus 8, which would be negative 10/15. And then as we reduce those, these are both divisible by 3, so that would be 2/5. These are both divisible by 5, so that would be negative 2/3. And so those would be the two answers that we got for that. Now, I'm going to do the same problem, but with the quadratic formula, because that is the final method that we're going to use. So 15x squared plus 4x minus 4 equals 0. Okay. So we have negative b plus or minus square root b squared minus 4ac all over 2a. A is 15, b is 4, c is negative 4, and so we plug in negative b, we get negative 4 plus or minus 4 squared minus 4 times a times c all over 2 times a. So we cross those out, we get 30, we get negative 60. Negative 60 times that would be a positive 240. And then 4 squared is going to be 16. So we get 256. I feel like this isn't going to work out the same way, but because 256 is not a perfect square. Or is it? $256. Oh, it is. Okay, so it's 16 times 16. So maybe it will work. So we do that. So it's negative 4 plus or minus 16 over 30. And so we have negative 4 plus 16, which would be 12 over 30. Then we have negative 4 minus 16, which would be negative 20 over 30. That's negative 2/3. And let's see, this is divisible by 6. So it's going to be 2/5. Was that the same thing we got up here? Yep, same thing we got up here. So we showed that both methods worked and gave us the same answer. If you need additional help, please come to Math Lab. Until then, calculator.